Okay. So once again, good afternoon, everyone. Today's lesson is limits of polynomial, rational, and radical functions. So as we all know, calculus, the limits are the backbones of the calculus or the basic calculus. So hold on. Someone wants to join the class. So in the previous lesson, the one that I've sent last night, we presented and illustrated the limit theorems. We start by the following limits. So when C, K, and L are real numbers and the function f of x and g of x defined on some open interval containing C except possibly at C. Ito yung sinasabi ko, mag-join ng class bago magsimula kasi nakaistorbo ako. So for number one, someone raising your hand. Christian, you want to say something or is it unintentional?
Unintentional po, sir, sorry.
Okay. So these are the limits of the theorem, the one that I've sent last night. I hope you were able to read and to do some practice exercises. These are common limit theorem that we are going to use all throughout this discussion. So you have the constant multiple, the limit of f of x as x approaches to c is equal to L, and the limit of f of x as x approaches to c is equal to m, then L is equal to m. The second theorem will be um, the limit of c as x approaches to c is equal to c, and the limit of x as x approaches to c is equal to c. And we have there the constant, the addition, the multiplication, division, power. I'll just read this one because I know I was able to forward this the other day. So suppose that the limit of f of x as x approaches to c is equal to L, and the limit of g of x as x approaches to c is equal to m. By constant multiple, the limit of k multiplied by g of x as x approaches to c is equal to k multiplied by m. For the addition, the limit of the function f of x plus minus g of x as x approaches to c, that will be equal to L plus minus m. For the multiplication, the limit of the function f of x multiplied by g of x as x approaches to c, that will be equal to L multiplied by m. For the division, the limit of f of x all over g of x as x approaches to c is equal to L over m, provided that m must not be equal to 0 because it will make our limit undefined. Power, the limit of f of x raised to the power of p as x approaches to c is equal to L raised to the power of p for p as a positive integer. And for the root and for the radical, the limit of f of x, the nth root of limit of f of x as x approaches to c is equal to the nth root of L for positive integers only, provided that L must be greater than 0 and n is an even number. Because when n is less than 0, then when L rather is less than 0, then L is would be an imaginary number. Okay. So let's start with this and let us use the theorem that we've mentioned earlier. So when I do the face-to-face classes, I make sure that this limit remain written on the board or in the manila paper all throughout the discussion of the lesson. However, since we are here in an online class, it's difficult for me to do it because I cannot split my screen just for this one. So I suggest you do the screenshot of this theorem, or print the one that I've sent the other day. So you have the guide on what limit theorem are you going to use. Okay, so let's start. So determine the limit of 2x plus 1 as x approaches to 1. So from the previous theorems that we've mentioned, we have there the limit of 2x plus 1 as x approaches to 1 will be equal to the limit of 2x as x approaches to 1 plus the limit of 1 as x approaches to 1. So this one is the addition theorem. And then we have 2 limit of x as x approaches to 1 plus the limit of x as x approaches to 1 is equal to 1. It's called the constant theorem. Or I mean, not theorem, but constant multiple. So you can now substitute. That is 2. A limit of x as x approaches to 1 will be equal to 1 plus 1. This is the limit of x as x approaches to c is equal to c. So I am writing at the right side of the solution the theorem that we use. So we have the 2 times 1 is 2 plus 1. So we have there 3. Then therefore, the limit of 2x plus 1 as x approaches to 1 is equal to 3. Do you need some, siguro in 30 seconds, you digest the solution there? Raise your hand, type your question if you want to ask clarification or others. If you are not going to unmute yourself, then I'll be considering that you understand this solution. Okay.
Sir,
Oh, sige. Christian,
sir, yung paano po nangyari yung sa addition, sir? Ano pong
um,
ginawa?
you go back with the limit, I mean the original problem. Limit of 2x plus 1 as x approaches to 1. So our function there will be 2x plus 1. Diba? It's addition. You can separate 2x plus 1 as 2x plus 1.
Okay po, thank you.
Did I answer your question?
Opo, sir.
Summary clarification. I think you would have a hard time understanding the limit theorem if you did not read the PDF file that I've sent the other day. It was a late notice. I understand that some of you were not able to read it. Okay, let's have number 2. So let us determine the limit of 2x cubed minus 4x squared plus 1 as x approaches to negative 1. So we have here the limit of 2x cubed as x approaches to negative 1 minus the limit of 4x squared as x approaches to negative 1 plus the limit of 1 as x approaches to negative 1. We can guess what is the theorem that we use in the first part of the solution. It's
Addition.
obviously, that's correct, Bon. Addition. Hold on. Okay, let's continue. So we have now um, 2 limit of x cubed as x approaches to negative 1 minus 4. I'm sorry, that's not 2, but 4. 4 limit of x squared as x approaches to negative 1 plus the limit of 1 as x approaches to negative 1 is equal to 1. What is the theorem that I use?
Constant multiple.
That is correct, Mark Lewis. It's called the constant multiple. And lastly, you have 2 negative 1 cubed minus 4. Our x squared is negative 1. So you can now substitute plus 1. So I'm using the power multiple. So then we have negative 1 cubed is negative 1 minus 4, negative 1 squared, it's positive 1 plus 1. So 2 times negative 1 is negative 2 minus 4 because negative 4 times 1 is negative 4 plus 1. Negative 4 minus negative 2 rather minus 4 is negative 6. Negative 6 plus 5, we have negative 5. And therefore, the limit of 2x cubed minus 4x squared plus 1 as x approaches to negative 1 is equal to negative 5. So example number 1 and example number 2 are um, solving like limits of a polynomial function. If you have no question, let's continue using the limit of the wala pa pala. Sige, I'll give you, can you do number 3 in 2 to 3 minutes? And then I will ask you to open your camera sana if you want to answer, just to show your solution. Sige, 2 minutes. Let's make it 3 minutes. Yeah, sure. Pasilip ng kanina. Can someone show his or her um, solution? Just open your camera and then you don't need to focus it. You don't need to focus in your face. You just have to focus it in your solution. Anyone? Okay. Sige. Mark 1 minute pa. I know some of you already discover a shortcut method. Someone is opening the Raymond. Raymond, akala ko pa naman mag-share na. I know that some of you already discovered the shortcut way without using the limit theorem. When you go to college and then you have some advanced subjects of calculus such as, yeah, that's correct, but I need the process actually, Miko. Can you show Miko the process? Oh, wait lang. I think I have to stop my share para makita kita. Sige, go ahead, Miko. Nakikita ka. Why can't I see it? Power theorem lang ginamit ko. That's okay. Miko, again. Makikita yan. Unmute yourself so you will be pinned by your classmate. Unmute yourself kahit hindi ka magsalita.
Sir, nakalapis.
Okay lang.
Malabo po.
Ayan. Magsalita ka lang. Limit of addition. Okay. I hope everyone can see it. The limit of x to the fourth as x approaches to 0 minus 2 limit of x as x approaches to 0 minus 1. That is constant multiple. That's correct. 3. Substitution. That is power. Very good. That is -1. I know some of you answered in the chat box like King, Renzo Escanilla, -1 din sagot ko. Mark Angelo, that's -1. Very good. Now, going back to my explanation, why do I need sir to answer or solve the limit using the limit theorem, where in fact there is a shortcut method to that? The answer is when you go to college and you have your advanced subjects like the advanced calculus, integral and differential calculus, your professor will ask you, why is it that the answer to this is -1? Then you will, the explanation there is just the limit theorem. Then you show to the teacher that the limit of 3x to the fourth minus 2x minus 1 as x approaches to 0 is equal to -1. So the explanation as to what your classmate Miko is sharing is that that will be limit of 3x to the fourth as x approaches to 0 minus the limit of 2x as x approaches to 0 minus limit of 1 as x approaches to 0. So the first step is you use the addition theorem of the limit. Then 3 limit of x to the fourth as x approaches to 0 minus, excuse me, minus 2 limit of um, x as x approaches to 0 minus 1. So this is the constant multiple. And then by substitution, minus 2 times 0 minus 1. This is the power. This is 0 minus 0 minus 1. So the limit that we are looking for is -1. Again, you can directly substitute 0 in the given function. The answer there is -1, but I want you to practice using the theorem. Because later on, we are not going to use anymore the theorem because you know the explanation behind. Clear? So we will now apply the limit theorems in evaluating rational function, such as this one. So usually in evaluating rational functions, we use the division rule. So when we use division rule, first we note that, by the way, the given is limit of 1 over x as x approaches to 1. So note that limit of x as x approaches to 1 is equal to 1. Since the limit of the denominator is non-zero, we can apply the division rule. So how do we apply the division rule? We have there the limit of 1 over x as x approaches to 1 is equal to the limit of 1 as x approaches to 1 all over the limit of x as x approaches to 1. This is the division um, theorem. So the limit of 1 as x approaches to 1 is 1. And the limit of x as x approaches to 1 is 1. So therefore, that is 1. Okay? Clear? Question? No question. So you understand. Very good. Let's have number 5. before I ask you to answer the next question. So let's evaluate the limit of x as over x plus 1 as x approaches to 2. So how do we start this one? We have now the limit of x, am I correct? As x approaches to positive 2 all over the limit of x plus 1 as x approaches to 2. So the limit of x as x approaches to 2 is equal to 2. Then in the denominator, the limit of x plus 1 as x approaches to 2 will be the limit of x as x approaches to 2 plus the limit of 1 as x approaches to 2. So this is 2 all over. The limit of x as x approaches to 2 is equal to 2. And then the limit of nasaan ako? As x approaches to 1, 2 rather is equals to 1. So this is 2 all over 3. Division rule. Okay, I'll give you 5 minutes to evaluate the limit of x minus 3 times x squared minus 2 all over x squared plus 1 as x approaches to 1. If you know the theorem that you use, you don't need to indicate it. King Renzo Escamilla answered negative 3 over 2. I think somehow in your solution you made a mistake. I don't know where. Can you double check? Lord Lorenzo answered positive 2, while King answered negative 3 over 2. Let us see later. We'll get the correct answer. Miko Isguera answered negative 6. Bon answered 1. Ariel answered 1. Mark Lewis answered 1. Carl Peter answered 1. Was Arshe Dugay 1. Mark Jim, ano Nuevo 1. Sherwin, ang laki ng sa akin. Yeah. Mark Angelo. You have to simplify Mark Angelo 2 over 2. Sige. I think some of you got it correctly. So let me show my solution. Kasi does anyone of you using their own tablet so they can share their screen? Oh, no one. Sige, let me share my solution na lang since some of you got it correctly. So we have there the limit of x minus 3 as x approaches to 1 multiplied by the limit of x squared minus 2 as x approaches to 1 all over the limit of x squared plus 1 as x approaches to 1. Then the limit of x minus the limit of 3 as x approaches to 1 as x approaches to 1 multiplied by the limit of x squared as x approaches to 1 minus the limit of 2 as x approaches to 1 all over the limit of x squared as x approaches to 1 plus the limit of 1 as x approaches to 1. So let us simplify now. Here, the limit of x as x approaches to 1 is equal to 1 minus the limit of 3 as x approaches to 1 is 3. The limit of x squared as x approaches to 1 is 1 squared minus the limit of 2 as x approaches to 1 is 2 all over the limit of x squared as x approaches to 1 is 1 squared plus the limit of 1 as x approaches to 1 is 1. So there will be negative 2 and then this will be negative 1 all over 2. So 1 squared is 1, minus 2 is negative 1 all over 2. So we have there 2 all over 2. So the limit of x squared, x minus 3 rather, times x squared minus 2 all over x squared plus 1 as x approaches to 1 is equal to positive 1. Very good. A lot actually got it correctly. While others, maybe you're still confused. We have the I'll just mention the names so got it correctly. We have Bon, Ariel got it correctly, Mark Luis, Carl Peter, Dugay, Mark Jim, Joshua, Sherwin got it also. One, Mark Angelo, and then King changed his answer. I know some of you got it correctly. You're ashamed of typing your answer. Ken, you want to say something? You're raising your hand. It was unintentional. Okay, so tama, it's unintentional. Let's have the radical function. So in getting the limit of a radical function, we have the limit of the x plus, for the square root of x plus 4 as x approaches to 0. So in your general math subject, the square root of x plus 4 as the function is defined when x plus 4 is greater than or equal to 0. Because it's not defined when the value of x plus 4 is less than 0 because that is imaginary. Remember, limit of x plus 4 as x approaches to 0 will be defined when this will be, kasi this is equal to 4. Am I correct? It should be greater than 0. Mali. Again. The limit here of x plus 4 as x approaches to 0 is equal to the square root of the limit of x plus 4 as x approaches to 0. So we have now the square root of 4 to 0 plus 4, so it's 2. Since the square root of 4 is plus minus 2, and according to the limit theorem, we are going to take only the positive value. Mhm. Here, the limit of x plus 4, square root of x plus 4, as x approaches to 0 is equal to 2. Can you do it? It actually, this will be the second to the last problem. So medyo, we are going to end the class 5 o'clock. Oh, Sherwin is past. He's quick to submit his answer as 8. -2 for Mark Jim. Bon, +2. Miko is Gera, -2. Duga is +2. Mark Jim said, basta 2, sir, di ko alam anong sign. You forgot the index in the problem. It's cube. Ariel Hidayo answered -2. Boa -2. Carl Peter -2. Okay, let's answer. So remember that the cube, since the index rather, not the cube, since the index of the radical sign is add, this is the index. We do not have to worry that the limit of a radical sign is negative. Okay, so we have now, can I directly substitute? Or sige, the limit of x approach, the limit of x squared plus 3x minus 6 as x approaches to -2 is equal to the cube root of -2 squared plus 3 times -2 minus 6. So the cube root of -2 squared is 4 minus 6. 3 times -2 is 6 minus 6. So we have there 4 minus 6 is -2 minus 6 cube root of -8. The cube root of -8 is -2 because -2 times -2 times -2 is equal to -8. So therefore, the limit of the cube root of x squared plus 3x minus 6 as x approaches to -2 is equal to -2. Very good. It's a fantastic work. Majority got it correctly. Let's have the last example. -8. You don't know, Mark Angelo, how to get the cube root of -8? Oh, Bon is quick to answer -3/5. Mark Tim answered -3/5. Lord Lorenzo, -3/5. Miko Alikdag. Okay. Gidokyo. I hope I pronounced it correctly. Dugay, Sherwin Rubiso, Kyle Garrido, Miko Isguera, Mark Luis Gonzalez. That is correct. So we have now the limit of 2x plus 5 as x approaches to 2, and then all over the limit of 1 minus 3x as x approaches to 2. So actually, I'm not sure if you are using the theorem, ha? Or you just substitute it directly. So malalaman ko yan when I gave the assignment kasi I will check the theorem that you are going to use. Okay? So I substitute it 2 times 2 plus 5 and the limit of 1 minus 3x as x approaches the 2. So this will be 9 all over 1 minus 6. So the square root of 9 is 3. 1 minus 6 is negative 5. So that's negative 3 all over 5. Very good. I think it's a common answer, negative 3 over 5. I haven't seen an answer different from negative 3 over 5. This is the assignment to be uploaded in the LMS. Now, for test 1, evaluate the following limits. You have to show there, 1 to 8, the theorem, just like the first solution that we have, this one. I need to see what theorem did you use. Is it addition, constant, power, and so on. And then I'll send it later. And then for not step 2, but quiz assignment number 2, this is a continuation of the lesson last week. You have to get the limit of this, and then you can answer 1 to 6 using the table. King Renzo, ano yon?
Sir, dun sa sinend nyo kahapon, sir, may naka-attach na activity dun sa limit,
Oo.
sir. Sasagutan din yun?
Sasagutan nyo yun. Anyway, wala naman yata ang dinigay kong deadline ay next week pa naman.
Linggo po,
So,
sir, nakalagay.
Okay, if you can, or if I see that majority cannot submit their work until Sunday, I am going to extend it. I'm not sure if you have a lot of works to do now. Sinasamantala ko kasi once na our lesson will be limit of infinite limits, and then the hardest part of this topic. So mukhang hindi ko na kayo mapagbibigyan doon. Kaya binibilisan ko siya kasi you know naman in Arellano, magulat ka, exam na pala. Wag mo na umalis. I'll be getting the attendance muna. Okay, discharge. And then save as. Bakit wala? Wait lang po ha. Kukunin ko attendance. Okay. Thank you for joining the class and see you next Monday.
Thank you, sir.
Thank you.
Thanks, sir.
Thank you, sir. Love you.
Thank you,
Thank
sir.
you, sir.
Thank you.
Thank you po, sir.
Pwede na po mag-leave.
Yeah.
Thank you,
I
sir.
guess